Welcome to the third video in our Class 18 series of lecture videos. We're continuing with Grignards and alkylithiums and their reactions. So, organometallic reagents continued. Alkylithiums, RLI, or alkyl magnesium halides, that is Grignards, as a source of some sort of alkyl carbanion. So let's say you have a general alkyl group bonded to magnesium and some sort of halide, as in a Grignard, and we put in some sort of ketone. So we've got R, and then on the carbonyl carbon we have R prime and R2. So we're going to form an alkoxide. We're forming this bond right there to the carbon that was formerly a carbon of a carbonyl. And we get this magnesium halide alkoxide salt complex. It's very basic. In a subsequent step, we add H3O+, which is acid, and we get an alcohol. If R prime and R2 are alkyl groups, so neither of them are hydrogens, this will be a tertiary alcohol. Let's see, methyl lithium, we're reacting with formaldehyde, which is a gas. Maybe we're bubbling the formaldehyde through a methyl lithium solution. Essentially, we're going to form a bond between the methyl group and a CH2 group, and of course we're still bonded to the oxygen, but now it has a single bond, and it's a lithium ethoxide base, and if we add HCl, we're going to lose our lithium chloride and we will form ethanol. So formaldehyde is a great way to extend a Grignard's alkyl group by CH2OH after reaction and then subsequent acidic step. Here we've got formaldehyde. We're adding isopropyl magnesium bromide followed by an aqueous acidic workup. And here we have isobutyl alcohol. So you can see how we've extended that isopropyl group by a CH2OH. So formaldehyde is a good reagent to extend a Grignard's alkyl component by CH2OH after aqueous acidic workup. So remember, you can't use a Grignard in a protic solvent. You have to do some Grignard step followed by aqueous acidic workup. So the trick with Grignard reactions or Grignard problems is actually quite simple. All you have to do is remember to draw your carbonyl group, and then whatever your metal was bonded to, whether it's magnesium or lithium, you form a bond there to that carbon that has the double bond with the oxygen, except you remember to put a single bond to the oxygen, and if there's a subsequent aqueous acidic workup, you add an H to the oxygen. The other group on this that isn't explicitly drawn is the hydrogen, but you know it's there. And in this reaction, we get this racemic alcohol. So we have a stereocenter, which is right there. And it could be R or it could be S. Here we've got benzaldehyde, so we draw our benzaldehyde again, except instead of a double bond to oxygen, we put a single bond. It becomes OH after aqueous acidic workup. Whatever the metal is bonded to, we draw a bond extending from that carbon that was formerly the carbonyl carbon, and then we replicate whatever was bonded to the metal. And of course, this also has a hydrogen that's not explicitly drawn. How about this? This is acetone, and this is tert-butyl magnesium bromide followed by aqueous acidic workup. Well, we draw the acetone part again, except instead of a double bond to oxygen, we put a single bond and it becomes an OH. And then what was bonded directly to the magnesium? That carbon, and it's bonded to 3 other carbons. Kind of looks like a dog that got hit by a car. Maybe it's broken back, turned around backwards. Okay, maybe it doesn't look like that. Maybe I'm just projecting. Pareidolia, right? Grignards can be used to incorporate things like deuterium. Here we've got 2-bromo 2-methyl propane. You treat it with magnesium, you create this Grignard. The magnesium inserts between the carbon and the bromine. If you add D2O, remember Grignards deprotonate water, so they will dedeuterate D2O, and you'll have a deuterium attached to whatever your metal was attached to, because they're very basic. And of course you have bromine and a magnesium deuteroxide salt. Interesting. Every year, I know students want to attack the oxygen and form a bond to oxygen at that Grignard carbon, but no, they really go after the hydrogens, or in this case, the deuterium. Here we've got iodocyclohexane. We add lithium, we would form an alkyl lithium. Of course, it's going to be excess lithium. And then we add D2O, and we've incorporated deuterium in our cyclohexane. Interestingly, lithium aluminum deuteride can go ahead and SN2 deuteride into an alkyl halide, as long as we're a nice primary alkyl halide. You can see that our 1-bromooctane here, the bromine has been replaced with deuterium. So it's a short video this time. I will see you next time.